Hi, this is Brian Kim. I'm going to share with you case number 175 in the best way to do cataract surgery series. This is a 1 to 2 plus dense lens, a tiny pupil, as well as intraoperative floppy iris syndrome. I'm going to show how double chop, cross chop, and mechanical fracturing techniques in the setting of a tiny pupil, but not only a tiny pupil, an IFIS pupil, allows me to very carefully and systematically disassemble this lens. Remember, if you're using mechanical forces, you're not using vacuum. And using mechanical fraction, you can very carefully disassemble the lens without vacuum, and you can go near the pupillary edge, not cause any trauma, and also it won't trigger the IFIS because you're removing less OVD with this technique. So you can see this is the eye. The pupil is rather small. I'm using a cotton tip to steady the eye. Use a corneal marker, which will help me center and size the rhexis. Of course, the rhexis is small, and so in those situations, it's a little bit more challenging to size the rhexis, but nonetheless, you'll see how I do this here. This is my paracentesis incision, first on the right side and then the left side. Make sure I'm flat to the iris plane, parallel to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine and then some intracameral epinephrine to see if I can stabilize and enlarge the pupil. You can see the billowing of the iris with the pulses of the epinephrine. This is some dispersive viscoelastic to fill the anterior chamber, coat the corneal endothelium, and flatten the anterior capsule. You can see there's a little bit of viscodilation, but not that much. And this is the triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel through the cornea, using the cannula to control the eye. And when I'm ready, I turn the cannula towards me, the eye towards me, and then I enter. And this is the sharp tip Haldi-Perkar forceps. I'm going to puncture the center. Pull down towards me, grabbing the right side of the tear, making sure I make the rhexis a little bit larger than the pupillary size because, again, that's in order to match the corneal mark that I made in the beginning. And remember, this pupil size is primarily due to that viscodilation. And you'll see how I'm able to very carefully perform lens disassembly in this setting and hopefully maintain as much OVD in the eye while doing so. This is the Capsulorhexis hydrodissection technique. I place a cannula under the rhexis edge contra-incisionally. Get a nice wave there. Come out and decompress on the left side, sweeping under the rhexis edge on the left side, and then turning towards the right side, doing the same thing, hooking the peripheral lens, then the lens begins to spin. Irrigating the surface of the eye, lifting the incision with a chopper, going in with irrigation off to minimize Descemet's trauma. Removing the surface epinuclear material, but you can see how the pupil tries to come down here. I place a chopper underneath the rhexis edge contra-incisionally, turning the phaco tip vertically sub-incisionally, fracturing the lens completely in half. That is the double chop maneuver. Placing the chopper underneath the right heminucleus, pulling it centrally towards the phaco tip, crushing the lens between the instruments, and that is the cross chop maneuver. You can see that sudden loss of resistance. Using the chopper to shield the pupillary edge, lifting that first quadrant up with some vacuum, and then crushing the lens between the instruments and very carefully removing the lens and emulsifying the lens piece, making sure I'm staying away from the pupillary edge while I emulsify. So let me show this in half speed. Again, pronating my hand, sliding the chopper underneath the rhexis edge contra-incisionally, turning the phaco tip vertically sub-incisionally, impaling the lens with the phaco tip, bringing the instruments together, fracturing and crushing the lens completely in half, and this bisects the lens completely. Separation shows that there's complete fracturing of the lens here. And I'm pronating my hand even more, sliding the chopper underneath the rhexis edge, making sure I'm underneath the capsule, sliding it to the equator, Turning vertical now, pulling it centrally toward the phaco tip. The phaco tip is essentially acting like a chopping block, and then I crush the lens with the chopper against the chopping block, which is the phaco tip. Using the chopper to shield the iris there, you can see I'm kind of tenting it up. Using the phaco tip to grab the first quadrant with some vacuum, popping it into the central safe zone, crushing the lens in half. Once the lens has been chopped, go ahead and use some vacuum to try to emulsify the lens piece, crushing the lens again into smaller pieces with the instruments, and the lens is being emulsified. Again, when I'm crushing, pay attention. When I'm crushing, vacuum's off. And that's the key there. When I crush, the vacuum's off. And once I crush the lens, and then I use a vacuum once I'm ready to emulsify. It's that constant on, off, which is particularly important in this case where there's a small pupil, but not just a small pupil, an IFIS pupil. So I rotate that lens piece, separating that second quadrant from the rest of the lens, getting around it with the chopper, pulling it centrally toward the phaco tip and crushing it again with another cross-chop maneuver. And then doing it one more time, using some vacuum to grab that one fragment up. Once I grab it up, I turn the vacuum off, crush the lens, and then activate vacuum again. And so that's what I'm saying. Just pay attention to that. When I'm ready to crush the lens, the vacuum's off. That is why I don't tend to grab the iris when I do this technique. I'm never going to accidentally perform ultrasonic energy on the iris by doing it this way. Turning the second heminucleus in front of me, placing the chopper around the lens piece. Now I have the phaco tip deep in the bag. I'm able to bisect the lens confidently, using some vacuum to grab that third quadrant, getting the chopper around it, crushing the lens in half, and then emulsifying the lens piece. Again, when I'm crushing the lens, no vacuum is used. When I'm ready to eat it, I use a vacuum and ultrasonic energy. And in doing so, I'm ensuring all the vacuum and ultrasonic energy is really being performed in the central safe zone, away from the pupillary edge. You can see I have exquisite control of the phaco handpiece and the chopper and the iris and everything going on in the eye here. And after doing successive crushing forces, you can see the rest of the lens tumbles out, as well as the epinucleus. So I take the chopper out, push BSS in, take the phaco tip out, and I go in with the INA handpiece. I always start subincisionally whenever I can, trying to peel the cortex from anterior to posterior. Obviously now here, I might grab the iris with the vacuum. Well, why? Because I have to use vacuum to peel off the cortex. And so that's really understandable here in this setting. I'm peeling the cortex from anterior to posterior, trying not to grab the pupillary edge whenever possible. But of course, I'm not utilizing ultrasonic energy because this is the INA handpiece, so this is very gentle. Even if you grab the iris, is not a big deal. You can just disengage it, use reflux, whatever you need to do. And very carefully, I'm trying to apply vacuum when I'm underneath the rhexis edge at the edge of the anterior capsule cortex. So I'm being mindful when I'm applying that vacuum in this setting here. Once I've removed the cortex, I switch to polish mode, polishing underneath the rhexis edge. And when I do that, invariably I'll snag some more cortex, switch to cortex mode, and then switch back to polish mode. Polishing the posterior capsule as well, looking for any fine wispy material, which there is some here, just very fine material there. And so again, the lens disassembly was very controlled with mechanical fracturing forces, double chop, cross chop, as you saw so well with this technique in this case. Pushing viscoelastic to fill the capsular bag. I'm skipping the polishing and the pulsing of the BSS and the subincisional capsule fornix due to the small pupil. So I go in with the lens, but I'm pushing viscoelastic as I do this as well. I'm turning the eye away from me, and that's because I want to see the rhexis edge on the contralateral side. And I'm able to see as I deliver the lens that the lens is definitely going into the bag and not into the sulcus. And these gummy lenses are nice in this setting. I can go in with the ID handpiece, activate irrigation, and then I can make sure that the trailing haptic goes into the bag. I like to use the Maltzman in this setting, which allows me to visualize the lens, making sure that both haptics are in the bag. Yep. The leading haptic's definitely in the bag. Get underneath the lens, tilting it and rotating it 90 degrees, and then ensuring that the trailing haptic is in the bag as well. Visualizing it here with the Maltzman. Removing the viscoelastic from within the bag. And this really illustrates how well this technique works. If you have a technique that relies on vacuum throughout the entire lens disassembly, what happens? You might accidentally remove too much OVD, and then that's when you get IFIS causing problems. And that's why you see all these cases of people eating the iris during phaco. Well, if you have a technique where you're only removing a donut of viscoelastic at the pupillary center in the central safe zone, then you don't really have to worry about using vacuum in other areas outside of that. Therefore, you'll use less vacuum indiscriminately, and you'll therefore have less OVD removal. And by doing it that way, you'll have less chance for the IFIS and the billowing of the iris to run wild. Remember, you want to think of the iris as being pushed down by sandbags, okay? And when you have the iris pushed down by sandbags, which is a OVD, it won't move. But if you start removing the sandbags, suddenly the iris is going to run wild. Or analogously, if you have a rabid dog that's on a chain, if it's chained down, it's not going to move. But if you remove the chain, of course, the dog's going to come after you. And so that's the same thing with IFIS. If you have OVD tamponing it down, then it's not going to start causing problems in the middle of your ultrasonic energy and lens disassembly removal. And so as you can see at the very end of the case, the pupil is quite small, and I don't really care about IFIS at the very end because I'm removing all the viscoelastic because I have to. This patient did quite well. You can see, again, fairly dense lens, but very controlled and systematic lens disassembly, using mechanical forces to disassemble the lens, not utilizing ultrasonic energy or vacuum with those steps, only initiating ultrasonic energy and vacuum in the central safe zone when I'm ready to emulsify. But whenever I crush the lens with mechanical forces, I am not applying any vacuum ultrasonic energy. And this patient did quite well with a nice clear cornea post-op day 1. So I hope this was helpful to you, and I thank you for your attention.